Good morning, everyone. In this session, we will continue our discussion on tension member, focusing especially on block shear failure and design strength governed by net cross section at the hole. In steel design, it is the important to check different failure mode to ensure safety. One such important mode is failure at net cross section, especially nearly bolt holes, and another critical mode is in block shear. In net cross-section concept, when the holes are provided at the bolt, the effective area of the member can be reduced. This area is called as net cross-section area. It plays a major role in determining the strength of the member. So in the net area design strength, it can be based on IS 800. So net area with plate with the hole with single hole, the area should be has been calculated B minus D into thickness. If you have two bolt holes, the net area has been changed B minus 2D into D. If the plate with different holes with some inclined part of the section, the bolt hole, the net area formula has been B minus ND summation of P squared by 4G into T. The minimum net area has been used in this design. The main design for tension member is gross area design strength and net area design strength has been calculated based on IS 800 in the design of tension member. The block shear failure is the common failure mode that occur near the end of tension member. In this case, the material fails along a path that introduces both tension and shear planes. In block shear, a part of the material tears in tension with another part failure in shear along the fasteners. So it is called combined failure mechanism involve two perpendicular planes. So this type of failure is occur around the bolt group or welded connection where the stresses are concentrated. So let us look at a typical example for box shear failure in gusset plate. Here one plane labeled to BC and C is subjected to tension. At the same time plane AB to B and C to D are subjected to shear. In angle section with bolt connection, the block shear can also occur. In this case, one plane experiences shear while the perpendicular plane undergo tension. So in welded connection case, the block shear failure is not limited to bolted connection. It can also occur in welded connection where the failure path forms around the welded region. In the design strength against the block shear is has been calculated for considering both tension and shear component. According to IS 800 2007, the class 6.4.1, the both yielding in shear and rupture in tension must be checked. So on block shear, so more than one bolt lineup, the plate it should be shear plane and tension plane as shown in figure. As per block shear design strength, it has been calculated the smaller value of these two. So yielding gross area in shear plus rupture net area in tension. So with these two values, which is smaller, we can consider for the block shear design strength. For welded connection, both shear strength is calculated for considering section around the weld my failure as a block. This commonly occur near bolt holes and welds must be checked in design. So understanding the block shear failure helps the design safer, more reliable steel structure. So thank you for this attention.